All right, this is going to be B-Sides, a workshop. This recording is probably very low quality, so I'm going to put it up in case anybody cares, but the noise is probably going to have a lot of background noise and everything, so I wouldn't expect too much. Anyway, I think it's close enough. Let's just start off here. So if you just walked in, get on the internet. There's how you get on the internet, and go to samsclass.info. Then on that page, you will find a box here and click on Violent Python. And what's going on here, you're going to learn how to do some simple attacks in Python. Here, no programming. This will help you very easy for you. And I should mention, I'm going to demonstrate stuff and walk around and try to show you for my progress. Some of you will be miles ahead of the rest, zipping ahead, which is fine. This is like a CTF. There's a series of challenges. And so just do them and you'll get on the scoreboard. If you click this Violent Python, you'll end up here. There's 3 levels of challenges. And then there's 2 more whole CTFs you can click on and do more of them if you run out of challenges. I would hate for anyone to be bored. But the beginners, Liz and I will go around and help people as they need help. And if you want, so you need to have Python of some kind. If you have a Mac or Linux, you've already got Python. If you have Windows, you have to install Python. Get Python 2.7. Unless you actually know Python 3, because Python 3 is very different. And I did everything here using Python 2.7. So if you open a terminal, you've already got Python on a Mac. So let me just go to a folder and make a directory, B-Sides. That'll do. All right. So there are 2 ways to use Python. Oh, one thing I should do, which I often forget, is in case anybody cares who I am, I'm Sam Bowne. I teach at City College San Francisco, right around here, and put all these classes for free on the internet. At least you can watch the videos. If you want to get credit, you have to actually sign up. That's free too now, by the way. But anyway, that's who I am. And Elizabeth is helping me out. And at the bottom of this page, there's some information about her. So you should hire her and give her vast wealth and power. So anyway, so if you go, you can use Python. If you don't know any programming at all, you should learn Python. It is the easiest and best way to get started because you can use it in a very simple way for a beginner, and it's actually powerful enough that you can do powerful stuff with it too. So if you only know one language, this is what most people want to know. And if you just type Python and nothing else, you'll be entering interactive mode of Python, which is what I used to use years and years ago on the Commodore VIC-12, VIC-20, and VIC-6, and Commodore 64. You can just type stuff like 1 + 1 and get 2. This is really easy. You can do some things right here in immediate mode without even writing scripts by just doing commands one by one. But most of the time, you want to exit that and make a file. So let me start with the first challenge here, and let's talk about it. The first thing we're going to do is make a port scanner and a banner grabber. This is the simplest network operation. This is what Nmap and Netcat do. And you could, of course, use the existing tools, but the point here is to learn how to write your own tools. So first, we're going to just duplicate the function of simple tools, and then we'll do things that are not so easy to do with the simple tools. So here's your first program. I'm just going to copy and paste this into a file. You can use any text editor you like. I'm in the habit of using Nano because it works even if you only have command line access, which is often the case when you've hacked into a server. If you are a real developer, you'll have a prettier environment you like using. So this is your first Python program, and this is why I recommend Python. Somebody else has done all the work in Python. There are libraries that do everything for you. All you have to do is learn how to import the library and use it for almost anything. So I import the socket library, which makes raw TCP sockets so I can connect to network ports. I create a socket object named S, and then I run the s.connect method to connect. Now you need 2 sets of parentheses here because just to give us a headache, instead of making a function that has 2 parameters, they made a function that has 1 parameter, which is a tuple containing 2 objects. So it's unnecessarily confusing, but all it means is you need 2 sets of parentheses around the URL and the port number. This will connect to my server on port 22. Then it will take whatever comes back, take the first 1024 bytes of it, and print it, and then close the socket. That's all this does. This is a banner grabber. This is one of the things Nmap does by default. You connect to a port, if it responds with some kind of banner, it collects the banner and shows it to you. So if it's a service that advertises what it is, you'll see that. So you save this file and run it with just Python file name. And that will connect to my server and then print out an SSH banner. It's a port 20 default Ubuntu install running on one of my servers. That's just the default banner telling you what version of SSH I'm using. So it's not very exciting, but this means I can now create my own network traffic programmatically, which means I can do attacks that involve manipulating the network traffic. So run it. Now the next thing is, what if you have errors? Let me disconnect from the Wi-Fi, or I'm not going to do that because I'm a little nervous about reconnecting. I'm going to change this to a port that is not open, like 23. That's Telnet, and I do not have Telnet running on my server. So if I connect to port 23, it's going to show me an error here, connection refused. But if I connect to port 80, it's just going to freeze on me. And let's do that. My server is serving up web pages on page 80. But if I do this, it's just going to sit here for a really long time and then time out. And the reason is because HTTP does not have a banner. It connects, it answers the handshake, and then waits for me to send a request, which I haven't sent, so it's just going to freeze up. So anyway, if you get tired of problems like that, you might want to add error handling. You can also just ignore this. So if you are an evil attacker, which is what I am, where you're hacking into things, programming is fun because you don't have to do a good job. A good program handles all the exceptions, gives useful instructions, useful error messages. If you're content to have your program just crash and print ugly things on the screen like this, you can just write code and attack things with sleazy little code that doesn't handle the errors. And that's what I generally do. That's what most attackers do, because I'm only going to make it run once and then I'm done. I'm not going to package it and sell 1 million copies. So I don't have to do the boring job of handling all the errors. If you want to handle errors, however, you can. You do it with this try except. And there's one other thing about this that is really worth knowing. So let me copy my grab to a thing called grab2. This, by the way, is another very good habit. As soon as you make anything work at all, save it and make a copy. Because when you modify it, you're very likely to break it. And then you're going to wish you could go back to the one that works. So I have a habit of always making version 1, version 2, version 3, version 4 of everything. Especially when you're developing exploits. You very often make a mistake and fall off the track and everything's shot. So let me edit my grab2. And here, I want to connect. I want to try to connect. I'm going to go back to 22. So you try. This is something that really baffled me about Python. Loops do not have drag brackets around them or anything. The way loops work is by indentation. So you try, and then you have a colon. That starts a loop. Now you have to indent the next line. There's spaces or tabs, and you have to keep indenting lines with exactly the same stuff. And that's what determines how much is in the loop. The loop is done when you stop indenting. At first, I was a C programmer, so I thought white space didn't matter. And if you copy and paste stuff from the web, you often get it all indented, and everything doesn't work. And I found this very frustrating until I understood Python's indentation policy. So except, so I put in except socket error as error, and if that happens, then print error. And that's it. So this is how you handle a condition. You try to do something. If it works, it will do this. If anything bad happens and causes an exception, it will go do this. That is error handling, and you can use it for anything else you want to try. So if you run that one, it works on port 22 just the same. If I go to port 23, it's going to fail and give me a less hostile message. It puts the connection refused right here. And I think before I got a little bit more than that. Anyway, so that's error handling for what it's worth. That's luxury. The last thing is timeout. Remember port 80. I connect to port 80 and it just freezes. So if I want to give up, instead of waiting for the default is to wait for something like 30 seconds or 2 minutes, which is very annoying. So you can fix that by setting the timeout here with set timeout 2. So let me add that. I'm going to copy my Python 2, grab 2 to grab 3. All right. Go to my grab 3 and put in s.setTimeout. Is it set timeout? Just a minute. It is set timeout. Okay. So 2 seconds. And now I want to make it go on port 80, so we will get something that will time out. And now it should do something less irritating than just freeze forever. Yep, after about 2 seconds, it gives up. So this is now a more friendly port scanner that will not just take forever and give you reasonable answers. So now that you've done that, the last thing would be make one that lets me specify the port. So here you can do raw input. Raw input will read from the keyboard and put whatever comes in a string variable. There are variable types in Python. So if you want to put it down here as a port number, you have to cast it to int to make it an integer. That's one thing that when I first started with Python, I got used to this. I very often would get error messages saying you have the wrong variable type. You have to get used to it, but it's not too bad. So let me put that in. This is going to be grab 4. All right, and then I'm going to grab 4. And now it's going to be print, enter port number, and then port equals int of raw input. All right, and now instead of connecting to a number I just type in, I connect to port. There, let's see if that works. Oops, no. There, all right. All right, so if I connect to 22, it works, okay. If I connect to 23, it's refused. Okay, so it's, now I got a glorious port scanner. I can scan one port. I've recreated the basic function of netcat. So now you can start finding things. By modifying this code, or indeed using it as it is, answer some challenges. First, you find a hidden service. I've got a server and it's listening on a port number ending in 000. So try them until you find it. And when you find it, you can get your name on a winner's page here. And then port knocking. Port knocking is a really old-fashioned way of having a hidden backdoor to the system. Used by very early malware and by administrators. You want to have a secret way for server. So they want to have something like an SSH port open. They don't want to open all the time. So they have a wizard. And when you have a knock on certain ports, it opens the SSH for 5 seconds and then closes it again. So the knock is connect to 3100, then connect to another number, which is between 31 and 3900. You'll have to try 9 guesses. And then 3003 will open for 5 seconds. So you have to do 3 connects. Connect to 31, connect to something middle, then connect to 3003. And if you do the knock correctly, 3003 will open and you'll get the data. There's a new version of this called single packet authorization, which is the modern updated way to do this, where you send a cryptographic signature in a single packet and it recognizes it. But this was the original way to have a secret way into a system. And that's it for the first set of challenges. So do that stuff. Let me see if anybody's on the board yet. I imagine some people have done it. Nobody on the board. Well, let's just go around and help people. Oh, there we are, people on the board. Okay. So several people have already done the first couple challenges, 1.1 and 1.2. And I just want to go around and help people and make sure everybody's on the road. If you've done that, just go on to the next ones. And I'll go around and see how people are doing. Once I see a lot of people finish the first couple, then I'll talk about the next one. I'm just going to pause this video while I wander around the room to make it slightly less useless for people. Let's see if I can figure out how to pause this later. All right, so for HTTP, let me start by just copying my grab. Take like grab 2 and put it in HTTP 1. HTTP. All right. So I'm going to connect on port 80. Now, when I connect, we've done this before, it just hangs because HTTP is not intended to be used this way. SSH is supposed to be used by human-typed commands. So you connect, it gives you a prompt, and you send a command. But HTTP is supposed to be used by a web browser, which knows what to send up. And it has to send a GET request or a head or something like that. So I'm going to start with a head request. And here's one. This is the simplest thing to send. So I have to send something to it. And what it wants to see is HTTP. You have to have a verb, which is usually get or post, but it can be head. Then you have slash, which is the URL of the page. That's referring to the default page of the website. And then the version of HTTP. Then you have to have a carriage return. And by the way, for modern Apache servers, you have to have both a carriage return and a line feed. And then you have to have a host name, which is your URL, and then 2 carriage return line feeds. That is the minimum acceptable HTTP request in HTTP version 1.1. So this might work and it might not. Let's give it a try. That's HTTP 1. Okay, it doesn't like it because I didn't define target. So let's do that. I'm just gonna put it up here. Target equals this. All right. All right, and so I'm gonna connect to the target. Since I have to use the same thing twice, it makes sense to put it in a variable. Okay, so now I'm gonna connect to it and then send a head request to it. And let's see if this works. And it did work. Okay, it might have failed. If I had a later version of Apache, it probably would have failed requiring the /r/n. But this version took it. So when HTTP requests reach the server, if you don't send a complete request, it just hangs the server, and that's the slow loris attack. It frees Apache servers very nicely. If you send a complete request, you get a status code back. If it's a good request, understood correctly, you get a 200 OK. Otherwise, you get something like a 500 or a 404 telling you that various things have failed. And then you always get a banner telling you about the server. And if it's a head request, this is all you get. Just the banner telling you about whatever the default information the server is handing out is. Now, if I want to do more, I'm going to try a login. What we're going to do is start breaking into websites. So I've got a login form here. So if I log in with foo and bar, let me make that as big as I can. All right. All right, so I put in foo and bar and log in. It tells me you entered foo and bar, credentials are rejected. Okay, so this is not a good password. So I might like to try to get in with a lot of passwords. All right, now I'm going to look at that in developer tools. So let's just go here. Chrome has developer tools, so does Firefox, and they're awesome. You find them someplace over here. Tools, developer tools. Okay, that gives me another pane of data about the website. And I'm going to go to the network tab, and then I'm going to log in again with foo and bar and log in. Okay, now over here, I have a login network request. And I'm going to make that bigger and click on that. And now I can see what was really sent to the server here. It sent something with post, and I can see the raw request over here with view source. This is what I want to do because HTTP is a very simple protocol. It sends plain text to the server, and it is readable text. So this is the request that was sent to the server. I can just put that directly in a Python script and send it. Now, if you could try to understand this and know the various meaning of all the fields, and that's a good exercise, but you don't really have to if you just want to break into a server. You can copy what happened here. This is all the stuff that has to go to the server. So let's put that in our script. I'm going to copy HTTP1 to HTTP2. And now I'm going to edit that. Okay, and now I'm going to prepare my request down here. So I'm going to make request. Now here's something awesome about Python. You have multi-line variables. If you use 3 quotes, I can put in that whole mess and then end it with 3 quotes. And it all fits in one variable. So I can send that to the server. The problem is, it's just going to freeze the server because it doesn't end with 2 characters per line. And the reason it doesn't is because there's another part to this request. This is a post. All this is the header information to go along with it, but I didn't send the username and password anywhere. The developer tools puts that down here. You have to hit view source, and that is this. So the developer tools don't exactly show you the whole request in its raw format. You have to do this. You have to put in /r/n, whoops, up down here. Okay. You have to put in carriage return, and then that. There. Now I've got a proper request. 2 carriage returns at the end to terminate the request, and then the parameters, which is username, foo, password is bar. So that's my request. So I'm going to send that instead of all this junk. I'm just going to send request. Okay, now let's run that one. Okay, now I've got a 200 okay. So my request was understood by the server, but I can't read anything that came back. It's just garbage. This is because to make web browsing faster, your browser zips stuff. It allows the server to zip the contents. Now I could, in fact, load a Python library and unzip it, but that's a lot of work. So I'm going to do something cheap and sleazy. But before I do anything, I'm going to save what I got, because this is working to some extent. So let's copy HTTP2 to HTTP3, and then edit that one. Okay. The problem is, in the header of my request, I put this thing called accept encoding zip. So I allowed the server to zip it. And I don't want to allow the server to zip it, so I'm just going to delete that line. If you don't tell it it's allowed to zip it, it won't. So now if I run this one, now I get readable text, HTML text that says you entered this, credentials rejected. So now I'm getting close to breaking into this server. I now can send a request from a program I can write, and I can read the responses. So now I can try a list of potential usernames and passwords until I get in with the brute force attack, and that's what I'm going to do. So what we're doing here is writing our own version of Hydra. So let me shrink this down a bit so I can see what's going on. There we go. And there we are. Okay. So let's go back here. And let me get rid of developer tools. I don't need them for the moment. Try and fit my instructions on the screen somehow. All right. All right. So once you got that working, you've done all that. Can have request plain text. We've done all this. Okay. Now, I'm going to be varying the username and password. So rather than having them hard-coded, I'm going to put them in variables. So I'll call username as foo and password bar. So let's modify this script again. So I'm going to copy HTTP3 to HTTP4. Okay, so let's have target up here, and then username. I'm just going to call it u equals foo, p equals bar. All right. I want to use variables instead of that. So down here, I want to take that and make it in u equals, and then plus username, and p equals. Okay, I've got in trouble here. Notice this triple quote is because I have a multi-line function, but now I'm trying to add things into it. I've got a problem. I really need to break this into 2 steps. So I'm going to end this much with triple quotes, and I'm going to call that request part 1. So that's request 1. Okay, and this stuff down here is going to be request 2, and that's going to equal, now we're getting somewhere, u equals plus u, and p equals plus p. And supposedly that will work. So I'm not going to change anything else right away in case I've made a mistake, which is entirely possible. I'm going to run this and see if I get the same response. If I fouled it up, I'll get an error message from the server. So let's see how this one looks. This is, by the way, another rule of programming. The #1 mistake that many programmers make is they jump on the keyboard and start writing stuff, and they write a whole page of stuff, and then, of course, nothing works, and they're lost. The way to program is to write just a couple lines or test it. Make just a couple more lines and test it. Then you know where your mistake is. And that's also why I saved all these partial versions, because you often make a horrible mistake and delete a bunch of stuff, and it turns out to be the stuff that was right, and you wish you could go back. So don't do much coding. Do a little coding and test it, and a little more and test it. So HTTP4. Okay, didn't like it because I made a mistake. I defined request up here, request 1, and request 2, but then I sent something called request. What I really need to send is request 1 plus request 2 here. Okay, let's see if that does it. Whoops, I spelled it wrong. Control V will go down a page. All right. It's request 2. Okay. Okay. Let's see if that works. Okay, it did work. It gave me the 200 okay, and it gave me the message. So now I can vary the username and password. There's one more fly in the ointment, however. Let's copy what I got here. Okay. I want to keep the Python extension on there just a minute. I'm going to do a move here. Okay. Okay. Here's my, now what I'd like to do is try a username like root. Now if I do this, root and bar, I'm going to have a problem. Let's run this one. Okay, now it's taking a long time. The server is not answering. And when it does, it's going to give me this. But if I look at what was entered, I entered root and bar, not root and bar. Now, the reason that happened is because there's a thing up here called content length. That tells it how many bytes of stuff are in that second part of the request. So if I'm going to change the length of this stuff, I need to change that number. If this is a root and bar, then the total length I'm sending is 12 bytes because you'll see it down here. It is 2 bytes here, then the username, then 1, 2, 3 bytes here, and then the password. So it's 5 plus the length of the username plus the length of the password. So when they're both 3 characters, that's 5 plus 3 plus 3, and that's 11. So I can calculate the length here. Length is 5 plus length of username plus length of password. So now I have the length, but that means I'm going to need to break my request up again here. That's request 1. This is going to be request 2. And this mess down here, I'm going to have to call that request 3. And now the thing I have to send is request 1 plus length plus request 2 plus request 3. That should do it. It's also going to fail. Maybe some of you already know why it's going to fail. Let's try this one. Now, I can't concatenate string and integer objects. The length was calculated by adding numbers together, so it's an integer. So I have to fix that by going down here and making this into a string. So this has to be string of length. There, that might do it. Let's try that. All right, now I got a 200 okay, that's good. And I sent root and bar. Okay, now I can send arbitrary names and passwords. I can pull them from a list. So now I can finally do a brute force attack and break into a server. So we dealt with the content length, and we can try a different password and username. You already know how to do that. So now you're almost ready. The one thing missing is you don't know how to make loops yet. So here's how you make some loops. Here's how you make a loop with alphabetic things. Just use square braces and make a list of objects, and it will try the first, second, and third. That's an alphabetic loop. And here's a numerical loop for I in range of 1 to 5. That will count from 1 to 5 and print them out. So now I can loop through usernames and I can loop through numbers. So now you can brute force a login form. So let me just point you to this challenge and warn you of a couple of common missteps. Okay, so here's the challenge. You have 4 possible usernames and 100 possible passwords. So you're going to have to do 400 requests. The most common thing I've seen students do is they try to use the script from the previous one. And if you do that, you're trying to break into that other form, which does not accept any of these passwords. So the first thing you have to do is use Chrome Developer Tools and find out the right request. The second thing, I might as well warn you, is you cannot do 400 requests with the same socket in Apache. By default, Apache only lets you make 100 requests before you have to disconnect and reconnect. So if you get too smart and you try to do all 400 in one double root, it'll crash. And there is a deep moral lesson here. Don't get fancy. The simplest procedure is usually the answer. I just did one username at a time. I'm hard coded. And that gets you to the end faster than being too smart. But anyway, this question is style. But anyway, give it a shot. You got one here to brute force into, and I think you got another one here. And you get points for that stuff. So give it a shot, and we'll go around and help you. Then I'll show you some of the later stuff. Let me see how people are doing. A bunch of people may already be done with that stuff. Yep, here's some people already done the challenge too. Just keep on going. All right, I'm gonna pause the recording again. Okay, resume recording. All right, so let me see how the scores are looking. That's not good. Maybe my network connection is no good. No, my network's all right. Oh, good. Okay, so we see we got 3 people that have done all the challenges in 1 and 2. The rest are doing some portion of it, which is fine. I just want to show you the best. And you may want to skip ahead if you're particularly interested in cryptography or if you're getting frustrated with the ones you're on. Anyway, so here's the next bit. I got password hashes and XOR encryption, a couple of very simple encryption issues. So password hashes are here. And let's talk about this. If you, back in the 90s or the 80s, you would actually store passwords in a plain text file in your computer, like in the etched password file. That, of course, is horrible, because when people see that file, they have all the passwords. So they moved up to hashing. So instead of storing password, you just store some long, garbled junk, which is created by running a hash function to scramble the password. Unfortunately, a lot of developers, primarily Microsoft, use terrible hash functions that do almost no good at all. Microsoft uses a hashing algorithm that is 1,000,000 times weaker than Linux and Mac for no reason at all. The reason, however, is because they did it in 1993 with Windows NT, and at that time, that is so long ago, MD5 did not even exist. So they used 1 round of MD4. That's all that existed at that time. But why they have never upgraded, I have no good answer. But anyway, so we can find out Windows password hashes. So in order to do it, like everything else in Python, you just import a library because it's all been done by other people. So let's start with this one. I'm going to do nano hash1.py. Okay, so I import a hash library, then I input a password, and then I create a new MD4 of password. So if I run this, okay, I put in a password of PASSWORD, and I get some weird thing that is not a password hash. This is because I mentioned before, Python is actually very sophisticated. It's object-oriented. You don't need to know that to do simple things. But in fact, what that import did is it created a hash object, and it is a data structure, and this is the address of the data structure. It contains more than one value of data tied to that object, which is fine, but this is not what I wanted. So to get what I wanted, to get a hash I can see, I need to add this hex digest to it. That will give me just the simple value expressed in hexadecimal instead of the complicated object, which contains more information. So I put that here. Okay. Okay, so now I get something that looks more like a hash, 8A9D, but if I look at the instructions, you will see that it's wrong. The actual hash of password is this, 8846. So I'm still getting it wrong, and that's because there is one more level of complexity. Windows is an international operating system. So it supports Arabic and Chinese and Japanese and everything. So it is not tied to ASCII. So the actual algorithm Microsoft used is first encode stuff with Unicode, 16 bits per character, and then perform one round of MD4. So you have to add that with this password encode UTF-16LE, which is some sort of code for Unicode. So let me put that on my screen and resize this so I can see it at the same time. All right, so I'm gonna, that's what has to go here, password.encode of UTF-16LE. If I've done that right, I should now get the right hash. When I give it password 8846, I think that's right. I was up here, the right answer was 8846. Okay, so now I can do Microsoft password hashes. And by the way, this is the way they really are, because Microsoft uses no salt. They use no salt and no stretching. The right way to do password hashes is first you add some random characters to the password, so that if two users choose the same password, they won't have the same hash. Then you go through something like 5,000 rounds of SHA-512, so it takes some significant amount of CPU time to do the hashing. That slows down attackers who have a dictionary of a million passwords. Now it's a lot of work for them to calculate those million hashes. Microsoft does neither of those things. If two users have the same password, they have the same hash, and it has never changed since 1993. So if you want to crack a Microsoft password hash, all you have to do is Google it. There are online dictionaries for the last 25 years with almost every password hash right there. You can also do it other ways, but anyway, that's so if you want to do it yourself, you can make a hash dictionary. And so here's the first job: make a dictionary that does all 2-digit hashes, Microsoft hashes for 2-digit pins, and it should end like this. That's a simple challenge, and then you have some challenges to do here. So I decided to make a pattern of hashes. So people are going to have usernames that look like this: CCSF-username-pin. Notice the username is lowercase. That gets a lot of people frustrated. If you put uppercases in the username, none of them will ever work, and you'll be frustrated. And now you hack into some accounts. Here are some password hashes. I made these accounts on a Windows machine, and I stole the password hashes with Kane, a hacking tool. So these are real Windows hashes. This is the way Microsoft Windows hashes look. You have the name of the user and a couple of empty fields. Then you have this thing, which is the old LM hash, which is so horrible, even Microsoft won't use it anymore. So it's just full of this AAD placeholder. It contains no information. The real hash is over here. The stuff after the last colon is the NTLM hash. And that is the thing you calculated before, which is one round of MD4 after Unicode encoding. So you should be able to make a dictionary and then look through your dictionary and crack these passwords. I have 3 users, and the password is in this form. There's only 100 possibilities for each one. And once you get them, you can log in here and put your name on some winners boards and get points. And then there was a cool online password hashing challenge, which I did for a week or so. It was great. We had 25 sets of password hashes and no information at all about how it was done. He said, just have at it. And it turns out it's really pretty easy to guess. I got like 21 of them because there's really only a few common hash functions. And what are you going to do? So I decided this one here is MD5 with many rounds, and you don't know how many rounds. So you're going to have to try rounds until you find a match. And this turns out to be much easier than you might think. And so then I have a third round where we use even more rounds of MD5, followed by even more rounds of SHA-1, and you don't know either of those numbers. And you're still fine. You can crack them without much difficulty and get in here. So that's password hashing. Now I think, let me just point you to the XOR while I'm here. It's probably the most efficient. I can choose the one that's most interesting. XOR is a very simple type of encryption. It might even be fair not to call it really encryption. XOR is one of the primitive operations used to transfer data, and a real encryption process has 3 or 4 things, like rearranging data, and XOR is one of them. But it's part of encryption, and it's often used as an obfuscation routine by people, particularly malware. Malware is where you really see these lame encryptions used because you just want to scramble things a little bit to confuse the analyst. You also see them used in obscure parts of the Windows operating system, where Microsoft just has a lot of legacy code that dates from the bad old days when they just didn't care. So anyway, That's where they actually use ROT13. If you save Internet Explorer favorites in Internet Explorer, in order to protect your privacy, the URLs are encoded in the registry with ROT13, which when I was a kid was the thing you got in a Captain Crunch cereal, a Captain Crunch decoder ring. Anyway, so we're going to use XOR. So XOR scrambles the bits one by one. So if you have keys on the left and data on the right, if the key is 0 and the data is 0, the answer is 0. If the key and the data are different, the answer is 1. If the key and data are both 1, you get 0. This is a information preserving operation, because if you feed in data that's half 1s and half 0s and XOR it, it will still be half 1s and half 0s, which is necessary because otherwise you could not reverse it. And you can reverse XOR by just doing it a second time. If you just XOR it again with the same key, all the bits that flipped the first time will flip again and get back to where they started. So that's cool. And in Python, you use the up arrow character Shift 6 to do an XOR. So you can XOR things here. So let's just do a couple of them. If I start Python, I can just run it in interactive mode for this. Here's Python, and I can set A equals A, and I can print A. Now here's that, print it as a letter. I can also print it as a number, which is ASCII or ORD. I think it's ORD of A. Yeah, now that's 65. And I could make it a hex number, hex of ORD of A, and that would be 0x to make, because hex, and it's 41. This is, the hex is the most valuable way to look at it here. Now, if I make another number, like B equals the numeral 3, and then I print ORD of B, it's 51. And if I print it in hex, it's 33. So now if I want to XOR those, let's do some simple cases to warm up. If I can print 0x, 0x01 in hex. You can use hexadecimal numbers directly, natively in Python. So here's 1, here's 3, and if I do an XOR, I can take 0x01 and XOR with 0x03. Now what happens is the 3 has 2 1s and the 1 has 1 1, so the 1 is going to flip to a 0. And let me just draw that for people for whom that is not clear, which we do it in detail here. All right, so if I have 3, 3 is 0 0 0 0 0 0 1 1, and 1 is in binary there. And if you XOR them, you get the zeros stay 0, these stay 0. Here the two numbers are different, so you get a 1, and here the numbers are the same, so you get a 0. So the answer is 2. So this is going to give me 2, and that's what's going on. Now if I take this 33 and I XOR it with 41, I get that number. Now that's kind of confusing. Let's put it in hex. There, and now I should be able to do that by hand to compare it. So let's just do it by hand to make sure everybody's with me here. So 33 in hex is in binary, and 41 in hex is 4 over here and 1 over here. So if you XOR them, where they're the same, you get 0. Here you get a 1 because they're different, and a 1 because they're different. And here you get zeros, 1, 0. So that is 7, 2. And that's what I got here. So that's how it works. XOR flips some of the bits and scrambles data and changes it into something else. So A XOR S is printable, and on you go. So we can do this in Python, and this is commonly done in CTFs and by simple obfuscation routines, or as part of more complicated crypto systems. So here's a whole program. Let's put it all in. Okay, gotta be, there we are. Okay, so this also introduces file IO, which is not too hard, but it's worth seeing. So nano x or 1.py. Okay, make my window bigger. Let's talk about this one. Okay, This user bin Python is there if you want to actually run it without putting Python before it. That's the shebang line, that's optional. Now I import sys. The sys library is going to be used for this. And so here I check to see how many input commands. I'm actually making a command which then has arguments on the command line. So it's going to be XOR1 in file out file K. So in fact, let me do something here. When you do this, you typically do not put the pi at the end. So let me obey that convention, and let's move this to just XOR. Oops, I want to move, I call it XOR1. Okay, now let's go back and nano it. Okay, so that's just a helpful argument, and this is how it's going to work. Take XOR, read the input from here, put the output in that file, and here's the key for a 1-byte key. So XOR that. So here's what, now I open the files. This is how you do it. F equals open. You take the file name from the argument list, and you read this one in binary, and the next one I open in append mode because that's my output file. And then key is the numerical value of the letter of the last argument, which is the letter by 1-byte key. So now I try reading a byte. As long as I find a byte and it's not nothing, then I just take that byte, turn it into a number, XOR it with this, then I write the character in the file. So this will do that XOR and write the output characters into the output file, and that's it. When you're done, close everything. So it's not very hard. And of course, by the way, in case you don't know, the way everybody does this, including me, is every time you can't do something, you Google and find Stack Exchange, and somebody has got a simple example doing whatever you want, and you just copy that and modify it a little. That's how all of us do everything, as far as I know. Unless you actually know something about a language, that's usually your best answer. And even when you do, every time I get an error message, I pretty much do that. Find some guy with an example of what causes this and how to fix it. Anyway, so that should do it. And let's see what I had here for an example to work on. Okay, we're going to encrypt a single character. So I'm going to put a capital A in a file called plain1. So I'll do that here. This will just echo that into a file. All right. So now I have a file that contains A, and you see it at the left here. I didn't even want a carriage return after the A. It's a single character. All right, so now I can XOR that with this. I can XOR it with S. So this, what didn't listen to me. This is a problem with Chrome. It often fails to copy. I'll just type it in. I can XOR 1. Oh, here's a problem. If you try to run your program, it's going to not run because permission is denied. If you're familiar with Unix, you know the problem. Even though I put the shebang line in, telling it was Python, you can't execute it until I give myself execute permission with chmod. Plus X, XOR 1. It's not an executable file until you do this. Now I can run it, and when I do, it's going to complain, it doesn't like my Python. How rude. Let's take a look. Nano my file. All right, let's try this. Env. There's two possibilities. One is that it's using the wrong version of Python. Let's see if this works. Okay, that's user bin env Python. We'll go to the environment directory and find where Python is. It's usually user bin Python, but maybe it's not on my machine. So anyway, now it's going to give me the error message telling me I didn't give it enough information. I have to give it an input file, which is plain1, and an output file, which is going to be cipher1, and then a key. And the key I wanted to use here was S, there. So now I can look at the output, which it put in this file, and it's a 2. So it took the capital A and turned it into a 2 by XORing it with a small s. That's what it does. All right. So now you can encrypt a whole text file, and you'll see why people like to call this encryption. If I make a file here, which is going to be, say, plain2, okay, some stuff. And then I encrypt that. And then cat cipher2. It turns into just all punctuation marks and garbage. That's the point. It really scrambles stuff, and it scrambles it so it's typically not ASCII anymore at all and contains funny characters. So that's why people think of it as encryption, but it's not very good encryption because you can just reverse it. If I XOR cipher2 here, and I call this decrypt 2, and then cat decrypt, it completely undoes itself. So that's one good property of XOR. XOR undoes itself when you XOR again with the same key. So now I can XOR a file with a single key, and now I can break into things. So here's a file. If you execute this curl command, it'll download a file from me. The key for this one is a capital letter from A to Z. So you only need to try 26 choices, and you'll get a message. Then when you're done with that one, you got one here where you have no information about the key, and you got to try all 256. And again, you'll get a readable plain text message when you find the right one. Then you got an image without the key. This is a ping file. So one thing is, how do you know when you get it right? And the way you do this is you choose some part of it that you know, and ping files always start with these 8 bytes. So you can do it a lot of ways, although what I highly recommend is to only decrypt 8 bytes until you find the key. That saves you a lot of time. Anyway, this is what you can tell when you get the right answer this way. And I think there's another one where you have a 2-byte key. You can use a 2-byte XOR key, then you encrypt the first byte with this key, next byte with that key, next byte with this key, next byte with that key. And you can have the key as long as you want. You just repeat the key as many times as necessary. This is a 2-byte key, and you can decrypt this stuff. And when you're done, it's a JPEG. So JPEGs start with this header. And when you're done, you can see the image, and it'll be a picture of something you can recognize. So anyway, give that stuff a shot. I'll go around and help people, and I may show you something beyond this if it looks like people are interested. Let me see how much time I have. I got till 2:15 and we're 1:20. That's probably enough, but I might show you a SAML thing at the end if people are interested. Anyway, I'm going to pause this and go around and help people. Zoom recording. All right. So I see people are doing these and they haven't gotten the challenge 4, but that's probably going to come to the people that are the high achievers. But I just thought I'd show you one more fun thing, which is burp. Burp and SAML. I got this working. It took me a week to get it working, so I'm happy with it. If you want to see how web requests really work, you use burp. So I'm going to use Firefox. You have to configure your browser to go through a proxy, which is in the settings. And what I do is I use Firefox just for this because I don't like Firefox much. I use Chrome for normal browsing, and I leave Firefox for testing websites with burp. So here's my burp. And if I just start it up, by default, burp is a proxy. It's listening on port 120, the local address on port 8080, and it starts out intercepting requests, which is pretty rude. You normally don't want that. That breaks the internet. So now it's letting traffic go through to the internet, and I can now load pages here. Now, normally, loading a secure page would give me an error message, but I imported the certificate into my browser and told it to trust burp. But that's neither here nor there, because this page is not secure anyway. Let me show you a SAML. This is actually pretty important in the real world. So I made this challenge page. Now, most of the internet works this way. You are at some provider that provides something like games or something, and you have to log in. But the provider does not really want to maintain a repository databases of usernames and passwords and everything, so you go to a third party to log in. So this is called the service provider, and mine is called sp.sam/.info. So everybody writes service providers, but only a few people write identity providers. And this is why everywhere you go, they say log in with Facebook, log in with Twitter, log in with Gmail to use my stuff, because I don't really want to be the guy holding the passwords and handling two-factor authentication and all that fancy stuff. I'm going to outsource that to one of those. So when you log in here, you click login, and you end up on a different server, and it has a whole different layout, and this is the identity provider, which mine is idp.samsclass.info. And you can log in here. There are 2 test accounts. User 1 and PWD is a test account. So you log into the identity provider. The identity provider sends you a token, and you now send the token up to the service provider who now says you're logged in as user 1. So the challenge here is to become admin. And the reason this is easy to do is because the service providers are typically small businesses and amateurs. They don't really know that much. They're just providing the service. They're trusting the identity provider to handle the identification. So if you are an underage person and you want to get into a bar to drink, you need to have an ID. Now there are two solutions. One would be to actually hack into the DMV and get a real ID that you're not allowed to have. And that would be really hard. What's a whole lot easier is to make a fake ID that's good enough to fool the bouncer at the bar, because they're an amateur and they probably aren't really looking too carefully at that ID, and that is the same on the web. So what you do is you forge an ID card that will fool the service provider, and that turns out to be very easy. The way this is normally done on the internet is SAML, Security Assertion Markup Language, and you can see it here. When I logged into the identity provider, it sent me a token, and in Burp you can see every request and response that happened over the internet in your browser that you're monitoring. So here in purple is the one that performed the SAML request, and the response sent me some information which was used, but I'm just going to go down here. After that I went, so here's the pattern. I started the service provider and I request a page. The service provider says you must be logged in to view that page, so go over to the identity provider and get some credentials. It takes me several back and forth with the identity provider to get my credentials, but when that's done, I get my credentials, and now I go back to the service provider, and this time I provide credentials. And the credentials you can see down here. The credentials are going to be in this request, there it is, this horrible thing called a SAML response. This long blob of base 64. That is my ID card that I got from the identity provider. And it looks complicated, but it's not very complicated, because it's just a blob of base 64, and inside the base 64 there's XML. Now you can decode it in Python, by the way, it's pretty easy, but you don't have to. Although actually, since we're in the Python course, let me give it a try. I'm going to double click it, right click and copy. Copy, and then let's see if I can decode this junk in Python. Python, and A equals this junk. Okay, and I already see a problem. The %3D is a URL encoded equal sign, and the %2B is, I think, a plus, so that's already kind of giving me a headache. So I'm not going to bother. You can do it in Python. But I don't want to get off track. That's not really the main point. You can put an extension in Burp called SAML Raider that does it for you. And so there's another way to do it, though, in the decoder, but I'll stick with SAML Raider. This is the simplest procedure. So what SAML Raider does is it follows a research paper. There was a research paper that came out about 5 years ago that reviewed the 14 current platforms that provided SAML and proved that 11 of them were insecure. And the reason is because they didn't really verify everything. So here is what that SAML request looks like. If you look at the bottom pane here, which I can blow up for the people in the room, although it will not blow up on the video, this is the contents of that thing once you remove the base 64 encoding. It is just XML, XML version, then a SAML response, then a bunch of fields, and see, it's got a signature, and then down here it's got a signature value and a certificate, and then it's got another signature value and another certificate. All this cryptography signs it, so you know that it's authentic. And what it signs is this security assertion: I am user 1 with this email address and that first name and that last name. That is my assertion, and all those signatures cryptographically prove that this is a valid SAML response. So if you do something like log in with Facebook and you correctly implement the API calls to verify the login, it will check all that stuff and make sure it's right. But if you have trouble setting up your service provider and you can't figure out how to do that, you might cut a corner or make a mistake and not really verify that stuff correctly. And if you just read this user and believe it, your site will appear to be working fine. It will just be hackable, and that's the case with mine. So that's the structure. So to hack in, you intercept it with Burp. You turn on intercept. Well, first I'll log out. Now I'm going to log in. I don't have the administrator credentials, but I have user 1 credentials. So I'll put in user 1 and PWD. Now I'll start intercepting with burp and log in. And when I log in, the first request is not interesting, so I'll forward that one. The second request is the one that has that SAML response in it. So this is the one that I would like to mess with, because this one is going to the service provider. This is the one that presents the ID card to the service provider. So I want to modify it on the way out, and SAML Raider will let me do that. So if I go down to the bottom here, and I take user 1, and I just put admin in there instead. This is like taking somebody else's driver's license, white out, put in your name, and then try to get in a bar with that. If they're really stupid, this will fool them. So let's see. I turn off intercept, and I go back to my browser, and I did not get in. I got an exception, and the exception is validation failed. So it is not that stupid. If you have just totally the wrong name, it does some of those cryptographic tests, and it doesn't get through. So that doesn't do it. So let's try something else. If I go back here, I'm going to log out again. I'm going to log in again with user 1 and PWD. Okay, I'm going to intercept this one and try a different attack. So here's the first request that's not interesting. Here's the request that has the SAML assertion. How about if I remove the signature? No signature at all, and then let it go. Now, I'm logged in as user 1. So this is called a fail open vulnerability, and it happens pretty often. The developer wrote some code saying, do some kind of math on the signature, compare it to some other value. If they match, that means it's good. But if the signature is just not there at all, then it triggers some kind of exception, and it misunderstands that exception as a valid response, not an invalid response. This happens quite often. You don't think of this edge case. So if I can get in with no signature at all, that means I can probably be administrator. Let's log out and log in and be user 1 again, because I have to pass the identity provider. And I'm not smart enough to hack the identity provider, so I'm not trying to lie to them. I always give them valid credentials. I'm only trying to fool the service provider, which is stupider. So I log in here, I forward this one. Now I remove the signature. And since there's no signature, I don't see why it won't let me change this to admin now. How is it going to know this is wrong? Now I turn off intercept, and now I'm logged in as admin. So this is, that's what that SAML Raider thing does. It does the attacks that worked against 11 of the 14 platforms a few years ago. Of course, all of them have been patched. At that time, even if you correctly implemented the platforms, these attacks would work. They patched them. So if you correctly implement exactly what you're supposed to do these days, then these attacks should no longer work. But as you know, especially if you've done any real development with crypto, it is often very, very frustrating. Things don't work, and you end up commenting things out for now and saying, we'll fix that later, and using it that way. And that's why the security auditors have to notice the holes in your system. So anyway, I thought I'd show you that. That's a fun one. And there's more ones like this. This is from the second CTF down here, the exploit development for beginners. So there's a few over here. These are not particularly Python oriented, but there are a bunch of ones here, and people had fun with them at another con I went to. So these are command injection ones. And down here, this one I just showed you was SAML forgery. And this blind injection one is one that actually involves a little bit of programming. That's where you identify things by measuring the time of response. And for that, you want to use Python to measure how long it takes to respond. Then you guess, and when you get the right answer, it takes a different amount of time. That's often what you have to do to find things out. Anyway, that's it. I'm going to stop the recording. We got 25 minutes left. I'll stick around and help anybody that wants help, but I'm not going to introduce any more new material, I think.